Hello everybody. This assignment is designed to provide you with the instructions to complete assignment 2. For assignment 2, what you'll be doing is an independent samples t-test. And in this case, you'll be comparing gender, or males and females, on their average GPA. So the research question that you might pose is, do males and females differ significantly on average GPA? Now, before we start this assignment, you're going to want to write up the context. And the context is found in the instructions for the SPSS data set. This talks about all the variables and how they're labeled, the values. And you'll notice for this data set, you want to make sure that males and females are labeled, and females equal 1 and males equal 2. Now, we did do that during the last assignment. Okay, back to the data set. So now, the first part of this data set, or the first part of this assignment that we want to do, is check the assumptions for the t-test. And the assumptions for any of our parametric tests, including the t-test, are that the variables are normally distributed so that the GPA for males and females is normally distributed, and that the variances for males and females on the GPA variable are similar. Now, they're not going to be exactly equal, but we don't want them to be significantly different. And our Levine's test, that's part of the t-test output, will tell us that. And then the last assumption is that the groups need to have or be independent, so that the data collected from males and females can't be related somehow. So what we're going to do to evaluate the assumptions is that we're going to go to Analyze, Descriptive Statistics, and I'm going to go to Explore. And my dependent variable in this case, the measurement variable, is GPA. And the factor list, or the factor, is gender. Now, the reason it's called a factor is because it's a variable that has two levels. And in this case, the levels are male and female. Now, you don't have to worry about clicking on statistics because it's going to give us all the descriptives that we're interested in for our analysis. But the plots, we probably should check none under box plots because we don't want a lot of different plots to look at, because that can be confusing. And then under descriptives, I would just check histogram. Now, you're going to get separate histograms for males and females, which are fine to paste into your report. But likewise, you can paste in the histograms that you developed during assignment 1 if you like. And then I'm going to check normality plots. Now, I'm not so interested in the normality plots as the table that's provided. And the part of the table or output that's provided with the normality plots is the results from the Shapiro-Wilks test. And the Shapiro-Wilks test is designed to determine if the distributions on GPA for males and females are significantly skewed or not. So then we can go continue, and then we can go OK. Now, in this case, you see that we have our numbers in the case processing summary. So you want to check those to make sure they add up to the total number that's in our analysis. And you see that the mean for females is 2.8967. And the mean for males is 2.5949. And then you see the variances and standard deviations for females, as well as the variances and standard deviations for males. So this gives you the descriptive statistics that we're interested in for our analysis. Oh, the other thing that we get are the skewedness and kurtosis values. And if you recall from the Warner text, and I think there's other resources, values that are above +2 or below -2 are problematic. But to determine whether those values are above +2 or -2, you must divide the standard error into the skewedness statistic as well as dividing this standard error in the kurtosis statistic. That way you'll get the value that you can compare to a plus or -2. Remember, if it exceeds those values, then you have data that's significantly skewed. But more easily, we can come down here to the Shapiro-Wilks test, and we see that the distribution of scores for females is significantly skewed. Males, it's not significantly skewed. And how do I know whether it's significant or not? Well, any value that's below 0.05 is significant. Any value that's above 0.05 is not significant. So if we look at this histogram for females, we can see that we sort of have a bimodal distribution. In other words, we have two peaks, and that we have skewedness here in the negative direction. This is the negative part of the distribution. Now males, it's not bimodal. We have a little kind of dip here, but for the most part I could put a normal curve over that. And so this distribution is not skewed. I'm going to ignore these normal probability plots. We don't need to worry about those. So we can see that from our looking at our or exploring our data that the female distribution is significantly skewed. We can also see that the males and females do have different GPAs, and the females are higher. But the question is the female mean GPA significantly higher than males when taking sampling error into account? We can also compare the variances, 0.557 and 0.583. And so the other question is, in terms of the assumptions, do those variances differ significantly? So we have one piece of our information to say something about the assumption of skewedness and kurtosis, or normality, and that's the Shapiro-Wilks test information. So now I'm going to go up and do the t-test. So I'm going to go to compare means and independent samples t-tests. And then our test variable again, or our dependent variable, is GPA. Our grouping variable or factor is gender. Now you have to define the groups. So we click on that, and we know that gender was 1, female was 1, and male was 2. And we continue, and we go OK. So this is our t-test output. Oops. This is our t-test output here. And we can see that when we look at our Levine's test, this is the test that tells us if our variances are significantly different. And the Levine's test is 0.566. That is non-significant because that value is way above 0.05. So if I go back up here and look at my variances, the variances for female is 0.557, the variance for male is 0.583. Those are very similar and not significantly different. So, two things. We see that the Levine's test is not significant, and so we've satisfied the assumption of equality of variances. We see also that from the Shapiro-Wilks test that one of our groups is skewed. So we don't satisfy the assumption of normality. However, the research tells us that if we violate one assumption, such as the skewedness assumption, or the normality assumption, but we satisfy the equality of variance assumption, then we can proceed with our t-test because it's not going to adversely affect the outcome. There's been lots of research done to show that. But the other thing we can do is, if this were to be significant, we could just drop down here and read the corrected results for our t-test. But in this case, since we've only violated one assumption, and that's the assumption of normality, we can go ahead and be fairly confident in our results. So in this case, this is really the part of the t-test analysis that's important, is our t-ratio is 2.004 with 103 degrees of freedom. Those are calculated by n minus 2 for the number of groups, or the number of individuals minus 2. Our two-tailed significance here is 0.048. So because this is below 0.05, we say the result is significant. The mean difference between male and female GPA is 0.30184. So if I go back up here and I subtract this mean from this mean, the female mean from the male mean, I'm going to obtain a difference of 0.30184. So this result is significant. So females are scoring significantly higher than males on mean GPA. Now, an important part of the analysis that you're asked to report is the effect size. So I'm going to show you how to do that right now. So if you look at your output for your independent samples t-test, you'll see that the mean for females is 2.896, the mean for males is 2.594. And to get D, Cohen's D, or the effect size for a t-test, we take mean 1 from mean 2. So we're going to subtract the female mean, 2.8967, from the male mean, 2.5949. And then we're going to divide it by the pooled standard deviation. The pooled standard deviation is simply the average of the male and female standard deviations for GPA. And so if I rounded off a little bit here to 2.90, and then I rounded this to 2.66, and then the average standard deviation is 0.755. If you divide the mean difference, which was 0.308 something, you can get that from your t-test output, divided by 0.755, the effect size is 0.40. And that's approaching a moderate effect if you look up the definition of effect sizes and the magnitude of those effect sizes in the Warner text. So you want to make sure that you report this as part of your interpretation. Okay, please let me know if you have questions. I'll be happy to answer them. Thank you for listening.